Hi everyone, welcome to lecture series. In the previous video, we discussed two important topics. One is for the introductions of probability, another is illustrations problem from the probability. In this lecture series video, we are going to discuss about the addition theorem of probability. So let's go to the video. What is addition theorem? A and B are any two events which is not mutually exclusive. Mutually exclusive, that is A intersection B is empty. Not mutually exclusive, A intersection B is not empty. Okay. If A and B are any two events and not mutually exclusive events, then probability of A union B is probability of A plus probability of B minus probability of A intersection B. That is addition theorem. It's important. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. But main things, these two events A and B are not mutually exclusive. Okay. Suppose A and B are mutually exclusive. What happened? A and B are mutually exclusive means the A intersection B is empty. So what is probability of empty set? Already we know. Probability of impossible event is equal to 0. Probability of empty set is empty event is 0. So probability of pi becomes 0. So therefore in this case probability of intersection B is pi. So probability of pi is equal to 0. Therefore we discussed this case. So probability of A union B is probability of A plus probability of B alone when if A and B are mutually exclusive. And you note that if A and B are independent events, then probability of A intersection B is probability of A into probability of B. So intersection when it is independent. Independent already you know the event A affects event B. That is independent. So sorry, event A does not affect event B. It is independent event. So here probability of A intersection B, if it is there, then each event is and its probability is separated multiple of each other. Probability of A intersection B is probability of A into probability of B. So now discuss a problem. Two students X and Y work independently. So independently on a problem. The probability that X solve the problem is 3 by 4. X solve the problem is 3 by 4 and the probability that Y will solve the problem is 2 by 3. So what is the probability that the problem will be solved, or what is the probability for the problem solved by the students? But the problem solving the two students independently. Okay, got the problem. Let A be the event of X solve the problem. So its possibility is also given is 3 by 4. Okay. Let A be the event of X solve the problem, that is probability of A is equal to 3 by 4. And Y solve the problem, its probability is 2 by 3. Therefore, let B be the event of Y solve the problem, that is probability of B is equal to 2 by 3. Right. Next, problem will be solved A or B. A or B. In probability, R means union and B means intersection. So probability for A union B. So we have the addition theorem. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. Then immediately we write that probability of A plus probability of B minus probability of A into probability of B. Why this case? It is both are independent. The two students solve the problem independently. Therefore probability of A intersection B is probability of A into probability of B. Everything is given. We put it that 3 by 4, 2 by 3 minus probability of A is 3 by 4, probability of B is 2 by 3. So we reduce that, the answer is 11 by 12. That's all. Check one more problem. The probability that a contractor will get a plumbing contract is 2 by 3 and the probability that he will not get electric contract is 5 by 9. So the probability of getting at least one contract is 4 by 5. So what is the probability that he will get both the contract? So it is another very useful results is that here. But what's the problem? The probability that a contractor will get a plumbing contract is 2 by 3. Let us take, let A be the event of a plumbing contract, that is probability of A is equal to 2 by 3. And B be the event of a electric contract, but here it is given he will not get the electric contract is 5 by 9. So when you get, so what is the probability for you will get the electric contract? This impossible is given. Therefore we convert this impossible to possible one. That means 1 minus probability of impossible. So let B be the event of electric contract, that is probability of B is 1 minus electric contract, because it is not get electric contract. 1 minus not electric contract means we get the electric contract, that is equal to 1 minus 5 by 9 is 4 by 9. Right. What's the question? And one more, the probability of getting at least one contract is 4 by 5. At least one contract means he get plumbing contract or electric contract. Okay, or means union. Okay. What is the probability that he will get both the contract? He will get plumbing contract as well as electric contract, and he will get electric contract and plumbing contract. And means into we calculate what is intersection value. Okay, what's the problem now? So here, what is his plumbing contract, plumbing contract or electric contract, or means we take union. Therefore, probability of A union B is 4 by 5. So the problem is the probability of contractor will get both the contract. That means probability of A intersection B. He will get plumbing contract as well as electric contract. Therefore, and into. Right. So probability of A union B is, because we connect all these things by additional theorem. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. So we know what is probability of A union B is 4 by 5, probability of A is 2 by 3, probability of B is 4 by 9. We find what is probability of A intersection B. So take these two and it will change. So probability of A intersection B is 2 by 3 plus 4 by 9. Take this 4 by 2 to right hand side. Then you reduce it. You get the answer 14 by 45. That's all. Finally, the problem in statistics is given to 3 students A, B, C, whose chances of solving it are 1 by 2, 1 by 3, 1 by 4 respectively. So what is the problem? Probability that the problem will be solved when the problem is solved, and what is the probability? So a problem is given to 3 students whose chances for solving it is 1 by 2. That is, A solve the problem and its possibility is 1 by 2. If B solve the problem, his possibility is 1 by 3. If C solve the problem, his possibility is 1 by 4. So it's everything is given. Therefore, we take the probability that A solve the problem is 1 by 2. The probability that B solve the problem, probability that B solve the problem is equal to 1 by 3. Probability that C solve the problem is 1 by 4. This everything is given. Right, we write it. What's the question? What is the probability that the problem will be solved? That is a problem solved by A or B or C, because the problem solved these 3 students independently. Therefore, we take the problem solved by A or B or C. How we get to 3 events? So probability for possible is 1 minus probability of impossible. We write that concept. Okay. So the problem solved by A or B or C is equal to 1 minus problem not solved by A or B or C. That is AC. So probability of A or means union. So probability of A union B union C is equal to 1 minus impossibility. Is possible, it is impossible. So 1 minus probability of A union B union C whole complement. By Demarcan law, what's the complement of this? Probability of A complement. Instead of union, the right intersection. Probability of B complement into probability of C complement. Okay, like this. Probability of A complement into probability of B complement into probability of C complement. Because by the Demarcan law, probability of A union B union C whole complement is A complement intersection B complement intersection C complements all are independent. Therefore, we write probability of A complement into probability of B complement into probability of C complement. Right? Is 1 minus, what is probability of A complement? It is 1 minus probability of A. Probability of impossible is 1 minus probability of possible. And the probability of B complement is 1 minus probability of B. Similarly, probability of C complement is 1 minus probability of C. Okay. We substitute all the value 1 minus chance for A is 1 by 2, 1 minus chance for B is 1 by 3, 1 minus chance for C is 1 by 4. So 1 minus 1 by 2, 2 by 3, 3 by 4. So 1 minus 1 by 2, 2 by 3, 3 by 4. Cancel these 2, cancel these 3. So 1 minus 1 by 4, that is equal to 3 by 4. There is a chance to the problem solved by A or B or C. Right? So in this series we discuss what is additional theorem and its its application for or related problems. In next sessions we discuss on the different types of the topics. I think it's the multiplication theorems, and still we discuss in the coming video, in coming lecture series we are discuss about the binomial distributions, Poisson distributions, so on. So we discuss all this. Thank you.